In this video, we will look at flowcharts with multiple nodes. So far, we have been mainly working with flowcharts with a start node, an end node, and just one addition node. But flowcharts can have multiple nodes. When a script gets complex, it is good practice to break it down into multiple nodes. Each node will have its own procedure, independent of the other procedures. The nodes are connected by links. There can only be a single link between any pair of nodes. When the script is executed, a 3D model will be passed down each link. The model is the output from the upstream node, and the input to the downstream node. The start and end nodes are special types of nodes. Firstly, unlike other nodes, they cannot be renamed or deleted. But in addition to that, they also have some other properties. The start node defines the flowchart parameters. The parameter values can be changed by the user in the dashboard. However, once the flowchart is executed, the values cannot be changed. All nodes in the flowchart can read these values, but none can write to them. This is a good thing, otherwise multiple nodes could be reading and writing at the same time. The outcome would then be unpredictable. The end node has additional option to return a value. This is only really relevant when working with global user-defined functions. They allow a whole flowchart to be treated as a single function and inserted into another flowchart. Such a flowchart may need to return a value. We will cover global user-defined functions in a later course. A flowchart can have multiple nodes. And the nodes do not necessarily need to be arranged into a linear order. Flowcharts can split, linking one upstream node to multiple downstream nodes. And flowcharts can merge, linking multiple upstream nodes to one downstream node. For a node with multiple outputs, the output model gets automatically copied by the system. The downstream nodes will get duplicates of exactly the same model. The copies are completely independent from one another. All this is done automatically by Mobius. A node can also have multiple inputs. In this case, the incoming models will get automatically merged into a single model. The merging process will copy all the entities into a single model. The procedure inside the node will only have access to the merged model. It does not have access to the separate input models. Again, all this is done automatically by Mobius. The merge process will merge entities with the same ID. So if two polygons have the same ID, then the polygons will be merged into a single polygon. In the example, the flowchart splits and merges again. The initial model contains 32 polygons. The flowchart splits, generating two models with 32 polygons each. Then in the final node, these two models are merged. You might now expect there to be 64 polygons. But that is not the case. This is because the models being merged have polygons with the same ID. So the final model will also contain only 32 polygons. This example demonstrates a common flowchart pattern using skeletons. This flowchart starts with a node that generates a skeleton geometry. This skeleton is a highly simplified representation of the final form. In this example, the model being generated is for a complex roof structure. The skeleton consists of a set of polylines. The skeleton is then passed to 5 other nodes. Each of the 5 nodes get a copy of the skeleton. And each of those nodes uses the skeleton to generate different parts of the roof structure. The output models from the 5 nodes then get merged into a single model. The execution order of the nodes in the flowchart is calculated whenever you click Execute. The order depends on the links between the nodes. It is not related to the names of the nodes. When executing a flowchart multiple times, re-executing code unnecessarily is avoided. So nodes that have not had their inputs changed will not be re-executed. In this example, if node 1 is edited, then both node 1 and node 3 will be re-executed. But node 2 would not be re-executed since its inputs have not changed. Lastly, no loops are allowed in the flowchart. Control flow constructs such as conditionals and looping can only be used inside procedures. In a flowchart with multiple nodes, data needs to be passed from upstream nodes to downstream nodes. The only way to do this is via the model. The upstream nodes needs to add the data to the model. The downstream node then needs to extract the required data back out of the model. In this example, we will focus on two nodes, the skeleton node and the floor node. The floor node receives the skeleton model and needs to generate the floor polygon. The skeleton consists of a series of arc polylines and stringer polylines. In order to generate the floor, the node needs to extract two polylines out of the skeleton. The floor polygon can then be generated from these two polylines.